Alamak. Okey tak?
Okey dah, madam.
Ya ke? Okey. Alright, so linear motion one dimension. I think this is you already familiar with this one. Even free falling pun, I think you have learned about the free falling during your secondary school. Okay, so tak apalah, it's just some revision. And the equation pun, I think you already familiar, but it's okay. So kita revise balik je lah, the one that you have learned during your secondary school. Okay, and then for distance, okay, distance is scalar quantity. Okay, so before we go for vector, okay, we see the scalar quantity dulu, which is yang same same physical quantities. Dia dealing dengan length, okay, macam distance dealing dengan length, but we call it as distance. So it's defined as the length of actual path between two points. So this is the example lah, okay. Okay, so means that distance we consider from point P to point Q, the actual path between two points, okay. So that is distance. Alright. So given here 25 centimeter. So what is the difference dengan displacement? Displacement ni dekat dalam buku survey guna G code D. Okay, so jangan ikut yang ni lah ya. Yang ni sebab saya ambil dari notes metric. Okay, so ada arrow at the above of the distance kita pakai displacement kita pakai X. Okay, X untuk yang dalam buku survey. Pakai reference book kita kan survey. Okay, so it's defined as the distance between initial point and final point in a straight line. So the straight line. Ataupun boleh panggil the shortest path. Okay. For example, let's say we have object P moves 30 meter to the east. After that, 15 meter to the south, and finally moves 40 meter to west. Determine the displacement of P relative to the original position. Okay, so so O to P is the displacement. So that's the difference dengan distance. So for this case, kalau tanya distance, so distance adalah yang ni lah. Ni totalkan ni, totalkan ni. Itu jadi distance. But when we consider the displacement, we need to consider lah the direction. Okay. So that's why bila kita dah plus minus the direction, at the end only this value of or this magnitude that we have. Okay. But distance, since we are not considering the the direction, so we total up the distance. But displacement, arah sini kita dah minus dengan arah sini. So yang ke atas ni, what's left is yang ke atas dan ke yang sini je saja. What's left, yang here, yang here. So that's why kita dapat the vector, the displacement is in this direction. Okay. So itu distance. Okay. Alright. So the magnitude given, displacement is 18 meter. But okay, the direction again we use as what we have learned before this. Okay, so 15 over 10. We get 56 degree from west to south. Okay. Ataupun kalau ikut buku survey dia guna south of west. Samalah maksud dia. Okay. Cuma dia dekat bawah tu dia arah ke bawah. Okay. Cuba positif. Alright. Okay. Kalau So the difference dengan distance. So distance dia, we might get 30, 30, 60, 70, 85. So different lah. So that's why kita kata macam displacement 18 meter. Tapi distance 85 meter. Okay, so that's the difference. Speed. Okay, so we define it as the rate of change of distance. The rate of change of distance. So scalar quantity, the equation change of distance over time interval. Okay. Ini pun kita guna delta X saya rasa. Okay, velocity. Velocity, we have average velocity. Okay. Which is defined as the rate of change of displacement. So change of displacement over time interval. Right? So X2 minus X1. Yang ni memang saya pakai ni X. Saya kat sini baru saya ubah. Yang ni saya lupa ubah. Okay, so time and dia punya travelling tu minus dengan the starting point punya time. Okay. So we get average velocity. Average velocity delta X over delta T. Same direction of the change in. Is the same direction of the change in displacement. Okay. So because here displacement, only displacement that the vector. Okay, so time is not vector, time is scalar. Okay, so the direction for V akan sama lah dengan X tu. Macam tu lah maksud dia. Okay. Kalau ada apa-apa tak apa boleh terus tanya ya. Jangan simpan-simpan nanti. Instantaneous velocity pula. Okay, just now is average velocity. So we consider the whole travelling punya velocity. Okay, so alright. So for instantaneous rate of change of displacement, ni kalau nak tengok dia punya part calculus dia lah. So we may write it like this. Okay, so delta X over delta T ada limit dia. Which is limit dia, delta T ni cannot be equal to 0. If 0, then the velocity cannot be exist lah. Okay, so dx, tukar jadi dx ya. Dx over dt is the instantaneous rate of change of displacement. Means that that distance at that time or at that point, what is the velocity? Contoh macam tu. Sebab tu dia kata instantaneous saja. Instantaneous tu kena pada at that time saja. Kalau average tu the one a range of distance. Tapi kalau instantaneous rate of change of displacement tu at that point berapa velocity dia? So that is your instantaneous velocity. So an object moves in a uniform velocity when when ds over dt constant. Maksudnya constant tu means that let's say so this is the distance. So nak letak apa kah nak letak kah ke apa? Kah lah yang paling senang. Lukislah kah. Tayar pun tak betul lah. Okay, so car dia moving. So this is the velocity. Okay, so velocity let's say so let's say at this point dia ada V1, at this point dia V2, at this point dia V3. Okay, but this one is your instantaneous. Okay, what I mean is your instantaneous. But if the case that V1 equal to V2 equal to V3, so means that you have constant velocity. So which may be the same as your punya average velocity. Okay, faham? Macam mana padam dia? Alright. Okay, so dia kata, and this level equals to the average velocity at any time. Samalah macam saya cakap tadi kat awak. Okay, dia dah cakap lagi. Alright. Manakah? Okay. Alright, so this one, when we plot motion graph ataupun we call it motion diagram kot. Okay. So maksudnya macam tu lah. Kita consider it's just like the gradient. So the it's just like a gradient. Okay, so cuma macam at this point, so we want to consider at point T1. Okay, at point T1. Okay, but to find it, we will use gradient. Okay, so gradient of xt graph is equal to the velocity. Now we're moving to acceleration. So acceleration is meter per squared because we divide the time 2 times. So your unit akan dapat meter per squared. So average acceleration is the rate of change of velocity. So velocity is the rate of change of distance. Okay. Acceleration, rate of change of velocity. So meter per second squared. So ada dua masa yang kita bahagikan. So for the average, we'll use change of velocity over time intervals where we can write the equation as in this form. Okay. So delta V over delta T. So its direction is in the same direction of motion. It is in the same direction of motion. Why? Because again, delta T is your scalar. So your acceleration, your direction akan sama macam yang your apply pada delta V motion lah. Okay, betul cakap apa pula ni? Direction of an object is uniform when the magnitude velocity change at a constant rate and along fixed direction. Okay, so uniform juga acceleration tu kalau velocity is not change.
Madam,
Ya.
apa maksud uniform acceleration?
Uniform acceleration tu macam contoh macam tadi kita kata uniform velocity kan. So the wall tu sama kan. So uniform acceleration pun sama macam tu. Maksudnya kita consider mana pen? Kita consider the wall travelling dia tu dia ada satu acceleration saja. Acceleration dia tak increasing. Dia accelerate but with the same value of acceleration. Okay, so same value lah. Contoh macam yang ni 25 contoh 25 meter per second squared. So sepanjang dia travel tu dia maintain acceleration dia. Okay. So that we call it as uniform. Okay. Boleh.
Okay, madam.
Alright, good. Okay, untuk instantaneous pula. Okay, untuk instantaneous acceleration is rate of change of velocity. Instantaneous juga. Okay, so bila instantaneous dia pada satu masa, means that your time cannot be zero. So different dengan average tadi, one of the time boleh jadi zero. Sebab we consider dari satu masa ke satu masa. So we consider a period of time. Tapi yang ni the delta T, the change tu cannot be zero lah, kita ada limit dia. So ini kita macam dua kali kita differentiate dia is become your acceleration. So an object moves in a uniform acceleration. Again, kalau dv over dt ni equal to a constant. Macam saya explain tadi lah. Okay, so dia jalan sama je. Dari awal pun memang dia dah 25. Macam tu. Okay. So kalau macam tu, that one kita consider the motion tu uniform acceleration. But when we have a starting at a starting point 0. Okay, so dia dari stop and then dia accelerate to another 1 point. Sampailah dia 25 meter per second squared. That one we need to find the average velocity. Okay, so kalau instantaneous acceleration, okay, yes, we consider a change of time. But kalau untuk yang when we find the value tu constant je, okay, then we will get we can explain explain lah yang that motion tu is in uniform acceleration equal to average acceleration at any time. Yes, okay, so where the instantaneous tu akan sama lah macam average acceleration, macam saya explain yang macam kereta tadi velocity, so sama dengan case acceleration ni. Alright, so deceleration. Okay, sebelum saya terlupa, acceleration ni ada positif, negatif. But the positive and negative tu, it depend on the direction. So to the right positive, to the left kita ambil negative. Okay, so since this one we are dealing with one dimension, so saya cakap kiri kanan je lah, sebab sekarang ni kita macam bermain dengan horizontal. Nanti next lecture baru yang kita masuk yang free falling one dimension but vertical. Okay, so yang ni saya cakap kiri kanan je lah. So that's why to the right we take it as positive and to the left we take the sign negative to show that dia pergi ke belakang. Okay. It's not the same dengan deceleration. Memang nama dia negative acceleration, but when the direction deceleration, it means that the object slowing down. So means that macam just now I explained to you, okay, acceleration tu mesti from 0, maksudnya dari rendah kepada tinggi. So barulah masuk dia accelerate. Okay, contoh 25 meter per second squared. So this is acceleration. Okay, acceleration. So dia meningkat. So accelerate. So dia membesut. Okay. So bila decelerate, it have negative acceleration. Bukan maksudnya dia pergi ke belakang. Bukan, it's not meaning that the value is negative 25. Okay, bukan ya. Okay, so negative acceleration means that the motion masih arah sini. Okay, contoh dia dah pergi dari 0 to, sekejap. Macam ada orang request ke? Sekejap ya. Okay, bukan. Betul ke ni? Okay. Alright. So, alright. So, slowing down mean, okay. So, let's say we have from 0 to 25. Okay, so dia moving macam tu. Okay, so maksudnya dekat sini dia accelerate lah. Okay, so dia accelerate dengan jayanya. Okay, kat sini. Alright. Okay, and then dia nak berhenti. Okay, dia pergi kepada 0 balik. Okay, so the object want to slowing down. To stop, want to stop. So here yang dia decelerate. But the direction, nampak tak direction ni? Direction dia pergi tu still in this direction. Bukannya tukar direction arah sini, tak. Okay. So the direction is still in this direction. Okay, so but the acceleration decrease. Maksudnya from the 25 jadi 0. The acceleration decrease. So that is deceleration. Tapi bila kita kata negative acceleration tu macam agak mengconfusekan kan. But I hope that you understand that it means that the object slowing down. So speed of the object decrease. So that will affect the acceleration. And we call it as deceleration.
Madam.
Ya.
Nak tanya dalam slide yang kita dapat dalam pre-recorded lecture video tu kan, dia kata decrease deceleration tu, maksudnya objek tu slowing down bila velocity dengan acceleration tu opposite direction. So contohnya velocity bergerak ke kiri, acceleration tu bergerak ke kanan. Macam tu. Itu objek tu slowing down.
Yang tu possible juga. Yang tu possible juga. Tapi basically kalau untuk explain deceleration, sebab yang tu bila kita consider graph graph dia akan nampak lah velocity tu negatif. Sebab ini kan speed of the object decrease with time. Tapi direction,
sebab saya tak faham bila dia kata acceleration tu bergerak opposite dengan velocity.
Acceleration tu velocity arah sini juga lah kan. Acceleration, dia cakap macam tu Sekejap, saya try tengok slide dia sekejap. Sekejap ya. Mana slide dia? Alamak, dah padam ke? Tak ada pula.
Yang kereta tadi ni ada? Yang kereta tadi yang ada 3.
Awak nampak ke saya tengah buka ni?
Nampak.
Oh ya ke? Saya ingat saya je nampak. Yang mana? Bukan yang ni. Atau lagi ya?
Bawah lagi.
Oh lagi. Ni?
Ni. Yang bawah tu.
Oh, okay. This car has a constant acceleration in the direction opposite its velocity. Tapi apa explanation dia? Dia cakap decelerate ni.
Tapi ada juga dia cakap, saya tak ingat lah mana satu dia punya tu.
Sebab yang ni dia kata car has a constant acceleration in the direction of its velocity. Okay, so tapi motion dia masih ke sini kan? Ni velocity dia. Acceleration ni, okay. Constant acceleration. Saya rasa dia nak cakap pasal ni juga, negative acceleration, sebab memang dekat kalau ikut terms dia akan guna negative acceleration tu. Tapi sebenarnya dia decelerate. Sebabnya velocity dia makin kurang. So acceleration dia decelerate. Dia decelerate ni, dia bukan cakap ni. Sebabnya macam kalau ikut slide saya pun, dia mention kat sini, dia guna terms negative acceleration kan. Mungkin sebab tu Survey dia buat lukisan macam tu. Untuk tunjuk dia slowing down. But the fact is, nampak tadi car tu moving kan, dia bukannya reverse kan? Maksudnya car tu masih moving the same direction, tapi dia negative acceleration. Maksudnya barulah kita dapat slowing down dia. Tapi it's not meaning that the direction of the car to change. Maksudnya bukannya tiba-tiba dia reverse, bukan? Faham tak? Macam tu ya.
Faham. Terima kasih, Madam.
Okay. Okay.
Madam,
Ya.
macam
Kenapa?
mana kita nak bezakan macam mana kita nak bezakan negative acceleration tu? Dia sama ada slowing down ataupun dia acceleration yang sama cuma opposite direction.
That one you need to refer to your punya direction of velocity lah. Faham tak? Okay, just in case memang ada case macam tu. Okay, ada case macam tu. Contoh kita ambil case decelerate. Okay, bila case decelerate, your velocity here, okay, you have V1, V2. So, V2 ni, kejap, V1 kurang. V1 kena lebih dari V2. So, dia jadi case deceleration. Okay, itu satu. But for case yang macam awak cakap apa, macam kita nak tahu dia decelerate ataupun dia sebenarnya dia ni, tiba-tiba acceleration dia yang negatif. Okay, sebab kalau deceleration ni, your acceleration tak negatif tau. Ke dapat negatif ah? Sekejap. Kalau ni kurang, kalau kita tolak, negatif lah kan? Patutlah dia cakap negative acceleration. Okay. Okay, so kalau, logiknya bila kita tolak contoh, kita masuk value kita tengok kita dapat negatif ke tak. Betul-betul dapat. Patutlah dia buat arah situ. Okay. So contoh kita ada 25 tadi. Okay, so this is your initial. So 0 minus 25 over berapa minit? 5 second contoh. Kita dapat negatif kan? Patutlah dia kata negative acceleration. Okay, so nampak tak? Kita dapat negatif. Okay, so kita cuba ambil case yang dia jalan straight. Okay, contoh dia jalan kosong. Boleh tak kosong? 25 lah. Okay, 25. Okay, saya tunjuk kawan contoh-contoh kita bagi case 25. Lepas tu dia patah balik. Dia patah balik dengan 25. Boleh tak case macam tu? Okay, so dia patah balik 25. Contoh. Sebab kita nak bagikannya apa? Negative motion tu kan? Negative, apa nama dia ni? Kita nak tunjukkan yang bahawa velocity kita sekarang negatif. For this case, bukan velocity yang negatif. Kita dapat tu sebab dia slowing down. Betul tak tolak? Tolak ke tambah? Saya dah tak ingat. Tolak ke tambah? Tolak. Average. Sekejap, tengok equation tadi. Saya confused pula. Mana tadi? Lama. Mana equation? Betul lah tolak. Okay. Betul. So tolak. So dia akan dapat macam tu. Okay. Okay, so contoh macam case tadi saya cakap tadi. Okay, kita dapat yang first case tadi. We get negative 5 meter per second squared. Okay, ni acceleration dia. Ni untuk yang deceleration lah. Okay. But untuk case yang velocity contoh, motion yang pertama dia velocity arah sini. Lepas tu dia patah balik tinggal barang kan. So velocity dia arah sini. So what happened to the acceleration? What happened to the acceleration? So the acceleration, kalau kita nak consider the whole punya acceleration ni, okay, so kita akan ambil V2 minus V1. Cumanya negative 25. Okay, negative 25 minus 25. Okay. So over 5 second. Macam tu. So we will not get the same value as this one. Okay, sebab yang ni kita consider dia pergi dan dia patah balik. But yes. Sebenarnya kita dapat negatif. Okay, patutlah disebut negatif acceleration. Okay. Sekarang dah terjawab lah kan. Kenapa dia lukis direction tu in that direction. Okay, so maksudnya the negative sign here ada dua maksud lah ya. Okay, so we have two meaning lah kalau dia negatif ni. But kalau untuk decelerate tu, you need to explain lah. Sebab tu saya cakap kalau negatif, positif your answer tu, you need to explain. Macam yang ni dia dapat negatif 50, 10. Okay. So dia dapat negatif 10. So menunjukkan acceleration dia ke arah sini. Okay. But this one, acceleration dia ke arah sini juga, tapi it used to explain the deceleration. Okay. So don't be confused. Boleh? Clear tak? Alright, good. Okay, so the gradient curve. So the gradient tu kita dapat sebagai acceleration untuk graph V versus time. Okay. Graphical method. Contoh kalau yang constant. So nampak tak gradient dia constant kan? Dari sini pun itulah value dia. Sini pun itulah value dia. Kat sini pun itulah value dia. So this one, for this case, we consider it as uniform velocity. Okay, for this case, berapa gradient yang kita boleh buat? Kita nak buat satu je ke? Tak. Akan ada banyak velocity. So means that the gradient increase with time. So yang ni rendah sikit. Nampak tak dia punya ni kan? Panggil apa panggil? Steeper. Tak ingat istilah dia. Makin stepper. Tak tahulah. Okay. So velocity increases with time. Sebab ni dia makin curam. Ni landai sikit. So maksudnya from here we can, yang ni X semua yang S tu tukar X saya lupa lah. Okay, so for this case pula, okay, at first, okay, we put 3 points. So P point yang macam mana? So dekat P ni mungkin increase. Okay. Alright, so R is negative. So the direction of velocity is changing. Maksudnya, it used to represent the velocity is direction. Okay, direction of velocity is changing. So mungkin dapat value yang sama, magnitude sama, lain. Okay, so at point Q pula 0. So dekat sini dia dekat dia punya ni. Okay, kita akan dapat point 0. Okay, P tadi increase lah. Okay, so velocity versus time adalah untuk sekejap ya. Yang ni velocity, okay. Just now displacement versus velocity. This time velocity, time. Okay, so if we have straight line. Okay, different ya. Just now kita punya graph X versus T. Untuk uniform adalah macam ni. Kita dapat uniform velocity. But for case untuk to plot graph uniform velocity, so velocity tu satu je lah. Masa berapa pun velocity tu satu je. Okay. For this case, untuk case yang second tadi. Yang equivalent dengan second tadi. Sebab apa? Dia velocity dia makin meningkat, which is involve uniform acceleration. Cuma kalau di straight line ni uniform acceleration lah. For this case pula, okay. So A kita ada apa? A dia kata speeding up. Okay, accelerate lah. Dekat B masih sama. Zero velocity, zero acceleration. Untuk C, dah start slowing down. Okay, so here dia kata area under the graph, kita boleh dapat displacement dia. Okay, so displacement dia. Alright. So, yang ni example. Berapa pada kita? 9. Okay, sempat lagi. Example. Example dari buku survey nanti awak pakai buku survey ke? Okay, so for example, we have this case. Okay. A toy